Hi, I'm Robert, and I'm here to tell you about a major part of JavaScript development, which is, as can be seen clearly, right, heap management. So yeah, so heap management in JavaScript is, it's a, okay. Yeah, well, remote management clearly doesn't work in this room. Yeah, so heap management is, okay, well, this is my topic for today, just checking if you're awake, guys. So yeah, let's try one again. So heap management is when you, nah, still not it. Okay, really this time, guys. Yeah, hype management is today's highlight. And in this talk, we're going to make a few minor yet perhaps insightful reflections on how we typically approach projects, starting and perhaps ever, hopefully finishing them, and how we pick our tools and manage complexity. So let's start this off. It's now Wednesday, the 9th of August, and yeah, 2017 this time. So so you're starting off to write a project. It's perhaps a personal project or for a client, but still you need to pick a framework. So you choose React, JS, perhaps Angular, or many of the cool kids on the block. Then you perhaps fast forward a few weeks, and you've now used it for quite a while, and the cracks start to show. Well, inevitably in every project, you start to find some dissatisfaction with your project, and that's where complexity and performance issues come in. So what happens then? What's the usual response to this kind of occurrence? Well, you guessed it. It's what's described in this book. You probably haven't read it because it really doesn't exist, but it doesn't need to either, because we all know the drill, right? You just take the whole thing, run a plow right smack in the middle, and yeah, here you go, new app. So what do you arrive at? Then it's you're now on board of the hype on the hype train. So you typically find a new solution that's probably got an even more bizarre acronym like Vue.js or who knows what else. It promises to be simple, revolutionary. It seems to be the simplest thing on earth, and you wonder why no one has ever invented it before. So, well, the first telltale sign of the hype train is easy examples. So, if you can find 3 easy examples of a tool's usage, and they don't do anything but they look cool, then it's probably the locomotive of the hype train. Now we'll see what happens in a minute, but you're probably in the beginning of the cycle. Now, if it's a new tool, so it has existed for like less than 1 year, then you probably are going to encounter some bugs. And the worst part is you can't even tell if it's a bug or a feature. Because, well, I remember my adventure with React.js a few years ago when it wasn't really properly documented. I mean, the large problem with it was that there was only one tutorial, and it was completely wrong, because the API had moved on, but the tutorial hadn't. So, yeah, here we are with API-less project. So that's a major point that I'd like to touch upon at the very beginning, and that's API documentation. It's really important, guys. So if all you've got are tutorials instead of API docs, then well, you're basically screwed. Now, once you've embarked on your second journey, actually, then you've also paid the cost of a rewrite already, and that's the time you pay for the actual rewrite and the bugs that you introduce into the logic that was tested in the first version of the project, and that you now have to rewrite and retest. And we'll see how this coupling impacts both front-end and back-end applications in a second. So, given that we've now established some probable bugs in the code, and even more bugs that we introduce redoing the logic. Why did we set out to do it in the first place? I've mentioned performance and complexity, and out of those two, we never really focus on performance first, but to make the program work. So when do we mostly branch out and start a new project? That's when complexity reaches its peak. So not to be worried, because the first thing we need to do is actually realize the source of our complexity. Every project has two sources of complexity, and one is the natural or the problem domain complexity. That's the minimum complexity that your solution needs to match the complexity of the problem. And you really can't go any lower. So if you start out a new project, then surely at the beginning, you are going to see that it's much simpler, but that's because it has less features. Yeah, that's pretty idiomatic, but well, it actually needs to be said out loud. And the other kind of the complexity is technical complexity that you add on top of your solution, and it's approached differently on different layers of our software. And we're going to see some solutions that can help us package this complexity and sell it out in batches. Now, one way of managing complexity and of separating it is microservices, which have conquered the backend world with with images like these. Now, what are microservices? In short, it's distributing your application in several separate and different, and that's the important word, different contexts that can run separately and communicate between one another. So by packaging our app in containers, or perhaps running them on separate hosts just to test if they can talk, we can achieve better software decoupling. So we apply the loose coupling principle on the highest level. That's on the level of system integration. And there's one often underestimated feature of microservices, and that's well, I've mentioned that you must set out to pick a framework at the beginning of your project. Well, what microservices often enable you to do, and that's often underestimated, is that you can actually pick different technologies for your different stacks, because the stacks are separate. So if you've got separate containers for your microservices, then you can for instance build an accounting part of your system, saying that perhaps one day we will arrive at a point when you can just give an API of a component to a prospective user and not worry about whether they're using some React UI router or Angular router. Just a thought. Now that we know how to put those pieces together, and what the challenges are in the coming years, let's see what actually makes a good library/framework. Now, we've said that your solution cannot possibly be smaller than the problem it solves. So instead of minimizing complexity of our application, we should try to look for ways to manage it. So, for instance, if we can find some pattern that helps us package the business logic into modules and integrate them somehow, be it via events or perhaps message passing on the front end, or other patterns that we can apply, then it's probably a better use of our work than just trying to cut down on features and be caught with the plow pattern all over. So yeah, it needs API documentation, and that applies to any library and framework we choose. So because it's often pretty easy to tell what a function does in the specific case when it's documented using a tutorial. However, a proper documentation for a function needs to include also the non-typical cases, and we need to know the entire behavior up front, or else we're bound to read the source code of the apps of the library, which is, well, not very convenient. And of course it needs to be maintained, and that goes without saying, but if you find something that hasn't been committed to for 5 years, then it's probably already toast. So yeah, just don't venture there. Now, a good database. That's my favorite topic, because well, I've been caught into the MongoDB trap a few years ago, and well, getting out of there took a while, given that we were designing an ERP system. So yeah, first of all, you need to know what kinds of data it stores. So for instance, if you've got Redis, the key value database, then obviously it relies on having keys and values. So you're probably able to build an indexing scheme on it, but well, it's not a good idea after all. Also, when choosing a database, you need to know its failure modes. Because, well, again, I'm looking at you, MongoDB. A few years ago, Mongo couldn't reliably cluster data. So if you had actually it's called replica sets, and it couldn't reliably roll back replica sets. So you should try and find out as much as you can about failure modes of a database. So basically, what happens if you pull the plug on the server or on a server farm? So yeah, that's a major part of signing up on your database. Of course, if you're writing front ends only and relying on serverless architecture which stores data for you, then it might seem like it's not very helpful to know what's actually on the other side. But that approach has its limitations. For instance, how do you know if your data actually persists? Even if the database API that you're using offers promise-based calls or perhaps callback-based, then you should double check with the API documentation whether it acknowledges the writes, so it resolves the promises after the writes have been buffered or perhaps flashed to the underlying storage. Because if you don't, you might find yourself with a pretty nasty surprise when your data's not there. So yeah, besides those intuitive functions, like your database should actually store data, it should also reflect your shape of your problem. So yeah, here we've got the Redis icon, and I've picked it specifically because it has those places for the inserts, for the various shaped inserts, and yeah, you should probably pick your backend to match the entirety of the problem's shape, and use multiple databases if you need to. Now, this is often the case if you're designing large systems, and to be honest, well, a few years ago I was using mostly MongoDB, and I was relying on its multi-indexing feature mostly, which is a great thing if you ask me, and we're gonna see that in the next slide. However, I was missing join features, and today I'm mostly on PostgreSQL, and I highly appreciate its aggregation features and joins, but on the other hand, we don't really have multi-indexing. So if you tag an item with multiple tags, then well, it's not as easy to query for. So so there's also one minor advice here, that the examples that you find online, so in to-dos or in readmes, seldom reflect real apps, because you're gonna have the other shapes of data that you have in the tutorials. And yeah, let's look at some example use cases for some popular databases. So if you're writing a database which stores blog posts with some tags, then you can use MongoDB just because it offers indexing of multi-values. So if you have a single field and with, for instance, an array inside that you can index it very easily, you just create an index, and by default it allows you to search by any of the values. Now, how do you solve issues such as referencing or storing names of users who comment on posts in your documents, because it's just JSON trees or hierarchical objects. So how do you display a user's name without joins? Well, that's actually pretty simple. You take the user's name and store it in the comment or in the post object. It doesn't change over time, but that's quite all right, because if users reply to one another, they use the at some username. So it's even better than actually referencing it via joins, because if you reference a user's name by a join or surname of someone, then if they change their display name, because they often do, then you end up with a broken reference, and the comments are even harder to read. So it's even better in some cases to actually freeze and capture and store the data in the document as a snapshot of a point in time. So your use case might be just that. Another use case when you actually need to display the current name of a product or of a company is relational data, and you really can't use any other database. I mean, there is then a relational database. So RDBMS stands for Relational Database Management System. Yeah. So that's MySQL, Mongo, and not Mongo, sorry, Postgre and stuff. So if you're trying to join data, you might be tempted to use GraphQL, and that's fine. But honestly, if you need to join data, then you should probably use a engine capable of that. So it's really that simple. Now let's look at some common front-end solutions as well, just to demonstrate that it takes some pattern thinking to find some common solutions that are, well, to be honest, pretty obvious. For instance, if you're making a corporate knowledge base that should be indexable, then you might want to make it a single-page app and make it have loaders render data from mesh app sources. But to be honest, it's way simpler to just make it static pages that Google or the competition, because they apparently still exist, like Bing or DuckDuckGo, that they can actually index. So yeah, if you make a site that generates static HTMLs, it's probably going to be faster, cheaper to host, and easier to find than your single-page app. Even though Google can now index dynamic pages, well, why make it do that? So another use case is the direct opposite, as it's a social network, and well, you guessed it, you already know the answer. So yeah, the right tool for the job, just a reinforcement of that idea. Now, what if you were not building a blog nor a knowledge base? Then there's a concept called now, it's not the most valuable player, though most of you may have heard it on some online games, or if you've watched sports. Well, I don't know if anyone here actually watches any sports, but yeah, well, we're online people, right? But yeah, the MVP, or the minimum viable product, is a concept often used in agile methods, and it's one very useful to determine the usefulness of the tools you've picked. Because the MVP states that you should build the smallest product that you could possibly run and ship to someone or just show online, and it's a principle that powers many startups today. And well, you just pick one feature that you think will be useful and add nothing more. So it not only allows you to test the business concept and what it looks like, but also the framework that powers it. So I think it's the fastest way to determine if your picked solution is the right solution. So that's about it. Now, whatever tools you pick and whatever architecture you arrange it in, remember that it's still your application and your responsibility. So whether you write your function yourself or include it from npm, just npm install. Apparently, the new npm release automatically saves your dependencies into package.json, even without the save flag, which is, I think, I learned pretty recently. Then whatever you use, it's still your application, and your users are still gonna see all the bugs that are inside. So remember leftpad? Leftpad was a trivial package on npm that well, what it did was, just pad strings by a given number of spaces, and it was probably a one-liner, but it disappeared from npm at some point. So, well, the smart thing would have been to just write the padding function yourself. But well, yeah, that's it only gets you so far. But still, I'd recommend just to just if you have a trivial function to write, then well, just maybe it's good to write it instead of including it from npm and lengthening your build time by 100 milliseconds, right? And that's about it, guys. So what have we learned today? Well, in terms of hard information, not much, but well, there's some valuable conclusions that should actually give us some insight into our own projects, which is we should actually look at our code and realize where the complexity, where the spaghetti actually comes from. Is it from our own silly ideas about what classes should be included, or is it actually a business requirement? So there's a quote that says that perfection is achieved when there is not when there is nothing left to add, but when there is nothing left to take away. So that's today's motto, apparently, and honestly, it's just a quote I picked on the spot. But yeah, we should realize that some of our complexity is indistinguishable from our project, and also we should always test our solutions and pick them according to the business need, and perhaps not on the current wave of hype that we're currently riding atop. And there's also a short addendum that I've added on building code. Well, it's not as abstract and vague as the rest of this talk, but I've personally think, and it's a matter of opinion for sure, but I think that building code can introduce some major trouble. For instance, well, sure, it's a necessary evil when doing front-end development still, but well, here's what it adds. It adds extra levels of source mappings, which can easily bring your bundle.js from 5 megabytes to over 30. And I've seen it happen. It's not a pretty sight. It can throw some coverage analysis tools off track, so that's another disadvantage. And well, surely you cannot get by without any of these. But there's one minor tip that I can give you when using code builders such as Webpack. It has a feature called aliases, which can let you change the string that you pass to require. For instance, if you pass something that looks like a legit library name, it can alias that to your local instance. And honestly, don't use it. Because, well, I've had a bug caused by it, and we couldn't test our application using Mocha because, well, the test runner we used kind of used Webpack, but didn't use the alias feature. So, yeah, again, keep it simple and keep what you run close to what you develop, and that's a recipe for an easier life on the front end and the back end if you do that kind of stuff there. So, yeah, that's about it. Yeah, I've referenced some stuff that I was partly inspired on, and that was the Daft Code's short rant on hype-driven development. Actually, I think it's an even better buzzword than what I've made up here today. So yeah, well, I'm not gonna click it for you now, but it's easily Googleable, even the buzzword here. So it's a nice rant, actually, worth a read, because it emphasizes the importance of architecture-driven development, not hype-driven. Yeah, also has some nice acronyms such as Stack Overflow driven development, and yeah, establishes some nice anti-patterns that we should all be aware of. So yeah, another one is a biggie, and that's hexagonal architecture. It's actually a big topic that I've only seen applied to backend applications till today, and it's definitely worth exploring. It's not a new concept, but it's a new name apparently for an old topic, and that means actually having an API at the most basic level. So it's a recommended read if you're into backend development. And well, for now, that's all, folks. Let's discuss.
Okay, so questions? Any questions? I just want to remind you that you can also ask questions through Twitter. So now if you tweet something with hashtag WarsawJS, I will read it to Robert, and he will answer the question. So you can, all people who are on live streaming can ask these questions. So any questions? So one question from me, Robert. What was your biggest difficulty with hype management you experienced?
Well, to be honest, I would mostly say that there's a lot of over-eager developers who would like to include every second library from NPM into their project, and that's a major risk that you take, because every dependency that you actually import is extra risk for bugs. You can also introduce security vulnerabilities that you have to manage. And while there are tools that aid you in this Herculean task, well, you still can break a project every now and then. So, well, also it has now raised our build times on CI to something over 2 or 3 minutes for the front end. So yeah, it's kind of heavy right now. So yeah, I remember a time when a programmer actually had their own a toolkit that they just brought from project to project. It was a silly file of functions, but it still served the purpose. And that's NPM now. So while I don't exactly long for the JavaScript of old from 10 years or so ago, well, that was a pleasant sight actually. That people knew how to implement functions and require them in their projects instead of npm install. So I think yeah, that more actual programming needs to happen and less importing of dependencies.